Hello friends, this question is from the subjects of network in the topic of network solution methodology. It's a 2 marks question. In a problem, the one circuit is given and we need to find out the value of resistance R, which is shown in the circuit. And it is also given that the current I is equal to the zero point 0.4 ampere. Value of this current I is equal to 0.4 ampere. So, first of all, let's name this node as a node Vx, and the current flowing from Vx to is Ix in this branch. Just name this like that. Similarly, the current flowing across resistance R is name it as a Iy. Okay, name it as Iy. Now let's apply the nodal at node Vx. Apply nodal at Vx. So at nodal, what we do, we actually apply the KCL, Kirchhoff's current law, that particular node, and as what we do in KCL, we assume the direction of the current. So in this case, I have already assumed the current Ix moving outward from the Vx. Similarly, I am assuming that other currents are also current flowing across other two branches is also moving outward. So from the KCL, we know that sum of the incoming current is equal to the sum of the outgoing current. I have assumed that all the three branches are going out, so all the three currents are outgoing currents. So their sum will be equal to 0. So let's write down the equation accordingly. To Vx minus 10, the voltage of this node will be 10 because it is connected to the 10 volt voltage source. So Vx minus 10 upon 5 plus Vx minus 0 upon 5, because this is my reference, which is equal to 0, plus Vx minus 2 by 5, because voltage across this node is 2, which is connected to the 2 volt battery supply, which is equal to the 0. Sum of these three currents equal to 0. So if I can solve this equation, I will get the value of Vx as 4 volt. By solving this equation, you can get the value of Vx as 4 volt. So you can see in this equation, in the diagram, that current Ix is nothing but a Vx minus 2 by 5, because current Ix is the current flowing in a resistor 5 ohm, this 5 ohm, which I have written as Vx minus 2 by 5. So I can calculate the value of Ix as Vx minus 2 by 5. I know my Vx is, which is 4 volt. 4 minus 2 by 5 is equal to the 0.4 ampere. Okay. So now let's apply the KCL at this node. Name this node as a Y, or name this node as a Z, just for the sake of difference. Name this node as a Z. If I may apply the current KCL at node Z, so I can see that my incoming currents are Ix and Iy, and my outgoing current is I. So my Ix plus Iy is equal to I. Here Ix I have just calculated, which is equal to the 0.4 ampere. 0.4 ampere. Iy I don't know, and I is already given in the problem. It is 0.4 ampere. My question says that current I is equal to 0.4 ampere. So I is already 0.4. So if in this problem you can say 0.4 and 0.4 cancel, so my Iy is 0. Because to satisfy the KCL at node Z, my Iy should be equal to 0. It means that current flowing across resistance R is 0. So what will the current across resistance R? The current across resistance R will be voltage across resistance R divided by R. What is the voltage across resistance R? Resistance R is connected between this 10 volt and this 2 volt. So voltage across resistance R, name it as a Vy, is equal to the 10 minus 2 is 8 volt. So if I may calculate my Iy as, Iy will be this Vy upon R. So Vy upon R, which is equal to 0. So I can, if I may calculate the R, I can transfer. So my R will be Vy by 0 or 8 by 0 or infinity. It means value of my resistor R is infinity. So you can see, friends, we have calculated the value of Ix, and I already know the current I. For this fact, I have got to know that my Iy is 0. If my Iy is 0, so my resistance is 0. It means that the the terminal is open circuited, because my current is 0 in open circuit. I know that current always flows in a closed path. So open circuit means resistance is infinity. That we have proved that. Okay, that we have also proved that because we have calculated the voltage across this terminal Y, and I have put the value of current 0, so which is terms out of infinity, which we, so theoretically also we know that, okay, the current 0 of a terminal means that it's an open circuit or infinity resistance. In this question, my right option is option C. Thank you.